Hello everyone, you are welcome to this class. So in this class, continue from where we stopped. So in our last class, we looked at some aspects of sex. So for today, we want to look at union, talk about union, we talked about intersection, we also talked about universal sex. But today we want to look at union and intersection of three sets. And after this one, we're going to look at there are laws that attach to union and intersection of three sets of sets. So we're going to look at that one in this video as we move on. So but before we go into details of this one, there's one thing that we did not do in our last video, which is what we call disjoint sets. Disjoint sets. Disjoint sets. So disjoint set. Two or more sets are said to be disjoint if they have no elements in common. For example, we have set A is 1, 2, 3, and then we have set B to be 4, 5, 6. So there is no element that is common to both sets. So in this set, sets A and B are disjoint sets. And if you want to represent this on the Venn diagram, this is how it's going to look like. This is A and this is B. They are two different things. This is A, this is B. They are not intersecting. We have 1, 2, 3, and we have 4, 5, 6. I hope this is very clear. So this one for disjoint set. When two sets have no common elements. So let's now go into this of today's class. So today we want to look at union and intersection of three sets. So we are given these three sets. Set A equals to this, B is this, and C is this. So the question asks us to draw a Venn diagram to show A intersection B intersection C and A intersection B and A intersection 1. A intersection B intersection C, and hence find the following. So we have 5 other things there. So what we're going to do first is we're going to have, so what we are telling us is that there is elements, or there are elements that are common to the three sets. So which we are going to do first. So if you draw a Venn diagram, take your ruler, draw a Venn diagram. So the first thing is draw a rectangle. So we have a rectangle here. So we have three sets. So we're going to have the rectangle I've explained earlier on. The rectangle is representing the universal set. So you are going to have this on it, or you have this on it. So that this rectangle is about universal set, but we are not given the universal set. So that's because we don't have universal set. So we have universal set for this set as well. So we're going to have this. To have this, and you have the third one, you overlap on it. Is that clear? We have A, we have B, and we have C. So we're going to look at the first thing before you put anything, any number, any elements in this Venn diagram. You should be able to get what is A intersection B intersection C. So A intersection B is where we have the same element common to the three of them, and that is 12 is here, 12 is here, 12 is here. We have 14 here, 14 here, 14 here. So which means A intersection B intersection C, the elements are 12 and what? 14. So that is what we're going to have at the middle here. So we can, let me extend this, let me redraw this, and let it be bigger than this. Okay. So let's have this way. So we're going to have 12, and we're going to have 14 here. So elements, this is where the three of them are common. This is for C, this is for A, and this is for what? B. So they are common. So what is common to them is 12 and 14. So having done that, we also need to look at where A and B, A intersection B, A intersection B, A intersection B. These all assist us. A intersection B, where what we have in A and also have in B. We have 10, 12, and what? 14. So mind you, 12 and 14 are already here. So in that case, the next one will only 10 here. I hope I'm making sense, because 12 and 13 is common to what? To this one. So you can see this is A is circle, and this is B. That's what is common to the two of them is what? 12, 10, 12, and what? 14. I hope I'm making sense. Then we go to A intersection C. A intersection C. So where A and C. So we consider A and then C. The first one is 11, and the next one is 12, and the next one is 14. So that is, so we have 12, and so what will be here is what? 11. Then the next one is what? B intersection C. B intersection C. So where B and C are intersecting. So B and C, so B, the first one is 12, right? The next one is what? 14. We have another one, and that is all. So we don't have, so which is still the same thing with this one. So there's nothing, we are not going to write anything. So that's what we do. So the next one, we start to look at what we're going to have here, the element we're going to have here, the element we're going to have here, the element we're going to have here. Now we look at A. So 10 is already here, 11 is there, 12 is there, 14 is there. So there's nothing that we're going to write here. So all the elements in A are 10, 11, 12, 13, 14. Then we go to B. So what we have in B, we have 10, 12, 14, and 15. So what we're going to write here is going to be 15. So what this one means is that there is no element that belongs to A only without belonging to any other set. Exactly. Then we go to C. So 11 is there, 12 is there, 14 is there, then 18 will be the last one. I hope this is very clear. So that is that. So we have drawn the Venn diagram. We have presented this from Venn diagram. We have shown that A intersection B and intersection C is here. So we can shape this aspect here. So we can shape it. That is where A intersect B and intersect C. But the question answers further that hence find A intersection B, A intersection in open bracket B intersection C. You have to be very careful with this type of question. You have A intersection in bracket B intersection C. So the first thing you need to do here is to find B intersection what? C. So B intersection C, we've already done it here. Then where is it intersecting A? So that is what we want to find out. So we're going to say that means we are combining B intersection C. We want to see where this one will intersect with A. Are you with me? So that means we're going to look at it. This is A here and B intersection C. So that is they are intersecting as of 12 and 14. So the answer is still what? 12, 14. How is very clear? Right? Then B, A intersection B, we close it, intersection C. So where A intersection B is this. Intersection C, that you are going to compare this one with C. So where we have, what do we have in common? We have 12 and 14 again. So that means it is what? 12 and what? 14. So I will see come back. So this will lead us to the rules. We want to look at the laws. Then C, A union C. A union into brackets A intersection B. So we have done union, and we are going to combine the elements in this one and this one. We combine it without repeating an element twice. So A union A intersection B. A intersection B is this one. Then union A. Union A. So we're going to write all the elements we have in And all the elements we have is what? A intersection what? B. So what we have here, we have 10, 11. So 11 is also, we don't have 11 here, we write it. 12, we have 12 there, we also have 12 here. 13 is there, and we don't have 13, and we write it. 14 and then 14. So that is A union A intersection open brackets A intersection B. Then D we have A intersection A intersect B union C. Alright? So A intersects B union C. B union C. So it's what we're going to look at first. So B union C, what's B union C? B union C. Let's write that one out first. B union C is that we're going to combine these two together. And that is going to give us 10, 11, 12, right, 14, and then 15, and then 18. Then A intersection this now, B union C. So we look at A and compare it with this one and see where they are intersecting. So 10, they are intersecting at 10, also intersecting at 11, and then 12. So we have 13 there, then 14. So that is A intersection B union C. Then the last one, because of the last one here, is A union B intersection C. Let's see what we're going to get. A union B intersection C, we have B intersection C here. Union A, that is all the elements we have in A and the elements we have in B intersection C, we combine them. So let's look at them together. We have 10 is there, 11 is also there. Here we don't have, we have 12. 12 is also there. It is union, don't forget. Then we have 13. We have 14. Do you have anything left? 12, 14, 12, 14, 10, 11, 12, 13, 14. 12, 10, 11, 12, 13, 14. So this is what we have. Now, one thing you're going to notice here, and that's what's going to lead us to the laws that we want to look at is this. If you look at this and this, we got the same answer. A intersection B intersection N, and this one we got the same answer with this. So we are not going to look at laws that are attached. You can see that we have union, intersection, and the likes here. So I'm not going to erase it. So we'll be able to use it to what? To look at the laws together. The first law we're going to look at is what we call cummutative law. So under cummutative law, just like when you have 2 plus 5 to give us 7, the same thing is saying we can write it as what? 5 plus what? Plus 2. Same thing with this one. So if I have A union B, so that's the first one. A union B is the same thing as saying B union A. And it's but to say A intersection B, I'm still saying what? B intersection what? A. So this is what we call cummutative what? Law. Then the second one is what? Associative what? Law. So associative law. So under associative law, it's like when you have, for instance, you have 2 plus 3 plus 5. 2 plus 3 plus 5. That means it's associative law. D. Associative laws. So we have 2 plus 3 plus 5. So this is simply as saying that 2 plus 3 in bracket plus 5. So this, that is 2. When you have this one, that should be 8. That gives us 10. The same thing with this one, this gives 5 plus 5. That is, we are still saying the same thing. So if I have A union B union C, I'm still saying it's still the same thing as what? A union B union C. That is the first one. We are still saying the same thing. So you are to have B, A intersection in bracket B intersection what? C. I'm still saying A intersection B, right? Intersection what? C. This is what we call associative what? Associative law. Example of this you can say 2 times 3 times 2. Same thing as 2 times 3, then times what? Times 2. That's still the same thing. Because 2 times this gives 6, I'll get 12. Here, it will give me what? 6 times what? Which is also what? 12. All is very clear. So the next one is distributive law. Distributive laws. So that one is also simple. So we are saying, for example, you have A, the first one is A union B intersection C. The same thing as saying A union B closes, then you distribute over this one, intersection A union what? C. So A union B intersection A union C. So that is A. B is when you have A intersection B union C. That's opposite. So this will give us A intersection B, then union A intersection what? C. So this is what we refer to as distributive law from set. So the first one is the union is distributive over the intersection. Why this one? Intersection is distributive over what? The union. So the next one is the fourth one, which is called the absorption law. Absorption law. Absorption law. Under the absorption law, you have A intersection A complement. So it's going to give us an empty set. So we don't have anything. There's no element, or you have this one. You have this one. So let's look at an example. So if A is 1, 2, 3, and A complement is, complement of A is say that the elements you have in the universal set that are not in what? In A is the A complement. So let us say this, the A complement, if the universal set is 1, 2, 3, 4, 5. These are the universal set. So which means A complement here is what? 4, 5. Now you have to find A intersection A complement. That's when you are finding intersection of a set and its complement. That's going to give you what? An empty set. So do we have anything in common here? So therefore the answer is what? Empty set. This is what we call absorption what? Absorption law. So the next one is under absorption law. If you look at this one, A intersection A union B. So what you are still going to get is A. Because if you combine A and U together, so you are now intersecting with A, you are expressing what? So this one will absorb B. So B will not even appear at all. So the answer is still what? A. And the last law we're going to look at here is what we call DeMorgan's law. DeMorgan's law. So this is the last one. First one is A union B complement. The same thing as what? A complement intersection B complement. So 1 B A intersection B complement is what? A complement union what? B what? Complement. And just the opposite of it. So this and this are the same. So we are going to look at example on this, how to apply this. So let's look at that. Right. So we're going to use this example to explain this law. So we are given that the universal set is 1 to 10, then set A is this, Y set B is this. So we have to show that A union B complement is equal to A complement intersection B complement. So this is Morgan's law, the fifth law I just explained. So to solve this, so the first thing we're going to do, we are going to solve this aspect and see what we're going to get. So solution. So the first is we look for A union B. A union B. That is, we are going to combine the elements in A and the elements in B together. So and that's going to give us 1, 2, 3, 4, 6, and 9, and then 10. So you notice that I did not repeat an element twice. This is A union B. So the next is to now find A union B, everything complement. That is, all the elements that are in universal sets and are not in this A union B. So we go to our universal set here. So and that will give us 1, 2, 3, 4. We have 4 of them in the universal set. 5 is in universal set. We don't have it here. 7 is in universal set. We don't have it here. 8 is in universal set, and we don't have it here as well. So this is A union B, everything was complement. So we that's that and that. So the next is, let's now prove this. A complement, intersection B complement. So let's look for A complement first. Then we find the intersection B complement also. So A complement, so are the elements we have in the universal set that are not in set A. So we have, so the first one is going to be 3. So we don't have 3 here, we have 3 here. So the next one is going to be 5. So the next one is going to be 7, 8, 9, 8, 9. That's all. Then B complement is going to be the elements we have in the universal set that are not in the set B. So we have 1 is there, 4, 5 as well, 7, 8, and what? 10. So this is B complement as well. So this is where we are going. So A complement intersection what? B complement. Let's see what we're going to have here. So we have 5 is complete. It's the section at 5, 7, and what? 8. So if you look at this, A union B complement, A intersection B complement are the same. Therefore, we can say that since A intersection A union B is equal to A union B complement is equal to 5, 7, 8, and then the A complement intersection B complement equal to the same thing, 5, 7, and 8. Therefore, A union B complement is equal to what? A complement intersection what? B complement. So that has proved one of the laws of Morgan's law of union and intersection of what? Sets. I hope this is very clear. So let's look at one more example before we end this video. Alright, this is example 2. So we have if P equals to 1, 2, 3, 4, and set Q is 3, 5, 6. Find P intersection Q. So solution to this. So this is A, P intersection Q, then be all the elements that are common to us, to P and Q. So 3 is common. We have 3 here, we have 3 here. That is all. So 3 is the only element that is common. Then P union Q. So we're going to combine the two sets together. That's going to be 1, 2, 3, 4, 5, and what? And 6. Then C. So we have P intersection Q union Q. So what we're going to have, we're going to combine P intersection Q, which is 3, then union Q. So union Q. So this is going to give us So we are considering P intersection Q, which is 3, and union Q. We combine the two of them together. That's going to give us 3, 5, and then what? 6. So if you look at this, this is also giving us Q, set Q. So this is what we call absorption what? Absorption law that I just explained. So P intersection Q, union Q is an absorption law. So the answer is C what? Q. Then D as well too. So we have P union Q, then intersection what? P. So we're going to have P union Q is this. Then intersection P. So we are looking at where P union Q and P intersect. This is going to give us absorption law. So the answer here will also give us what? P. So let's look at it together. So P union Q is this, intersection P. So that's going to give us where they are intersecting. So P 1, 2, 3, 4. So which is the same thing as P. So it's also an absorption law. So that is that on this video. This is what we're going to stop in the video today. So in the next video, we're going to look at the application of Venn diagram to solve problems in sets. So that is that. So if you are new to this channel, don't forget to subscribe and make sure you turn on the notification bell. So anytime I release video like this, you're able to have access to it. So we're going to meet in the next video. Bye for now.